Hi, welcome back. We are looking at what happens when the terminal arm is on the X or the Y axis. This is part 3 of the Castrol lesson. And these angles are also called quadrantal angles. You don't have to remember that word as long as you know how to process the information when the terminal arm is on the X or the Y axis, right? Right, so we will start off with a GeoGebra file. Okay, just bear with me. Here we go. So there's a point P and it's moving around in a circle. And as it moves around, you can see that the Y coordinate and the X coordinate change, or the values of the X and the Y coordinates change. Now, when we start close to 0, and then we keep going from 0 to 90 degrees, the Y value keeps increasing and the X value keeps decreasing, right? And at 90 degrees, the Y value coincides with the length of the radius and X value becomes 0. As we go from 90 to 180 degrees, the Y value keeps decreasing and the X value keeps increasing. And at 180 degrees, the value of X is equal to the negative value of the radius. So if the radius was 3 units, X would be -3, while the Y value is 0. Now, as we move from 180 to 270 degrees, X value, right? This is the X value. It keeps decreasing and the Y value begins to increase in value. And at 270 degrees, Y is equal to the negative value of the radius. So if the radius was 3, Y would be -3 and X is 0. As we go from 270 to 270 to 360 degrees, which is going to coincide with 0, Y value again begins to diminish and becomes 0, and X value becomes equal to the radius. Okay, so that is what happens as we go around in a circle, right? So please bear with me for a few seconds as I change from my laptop to my iPad. All right, so here we go. We've looked at the unit circle and we just seen what happens to the point, say a general point on, say any general point. Sorry, this circle is shaded. I didn't mean for it to be shaded, but I'm just not about to go fix that right now. Okay, so some point P, X comma Y, and we drop a perpendicular always to the X-axis. That's R. This is X, this is Y, and this is theta. So we know sine theta is opposite over hypotenuse, so that's got to be Y over R. Cos theta is adjacent over hypotenuse, so that is going to be X over R. And tan theta is opposite over adjacent, so Y over X. Now, you got to remember this because we are going to be falling back on this time and time again, all right? So sine theta is Y over R, excuse me, cos theta is X over R, and tan theta is Y over X. So for the very first question, we want to find cos of 90 degrees, right? So where is 90 degrees? It's right here. So that is 90 degrees, okay? At 90 degrees, what happens to X? X is 0, Y is equal to R, and we're going to use that information to see what happens to cos of 90. Now, cos of theta, as we know, okay, if we look at this, this triangle that I just set up in the last slide, so that is Y, this is X, this is R. Okay, I'm just going to copy this so that I don't have to keep writing this every time, right? And cos theta, so that is theta. Just copy this. Oops. There we go. Right. So cos theta is x over r, right? X is 0, so cos of 90 degrees is 0 divided by r. So 0 divided by any number is 0, so cos of 90 is 0. Okay, it's just simple, right? So you have cos of 90 is 0. Okay. All right, so we've done one question. Let's move on to another example. Find tan of 270. So the very first thing we need to do is draw the terminal arm. 270 degrees is over here. Okay, so that is theta is 270 degrees. And at 270 degrees, the value of x is 0, the value of y is negative r. And I'm going to try and paste something here. There we go. And if I have tan theta is opposite over adjacent. Okay. So tan of 270 is the y value, which is negative r divided by the x value, which is 0. Okay. So any number divided by 0 is going to give me an undefined value. So we're going to write that as tan of 270 is undefined. Okay. So that is tan of 270. Moving on, find sine of negative 270. So negative angles are clockwise. So this is negative 90, negative 180, negative 270, right? So our terminal arm is right here. Okay. So this is negative 270 degrees. Okay. Right. At theta equals negative 270 degrees, the x value is 0. Y value coincides with r, so that is that. And let's paste this here again. And sine of theta is opposite over hypotenuse, so y over r. So sine of negative 270 degrees is y value is r, x value is all y value is r is just going to be r. So sine of negative 270 degrees is 1. Okay, so that is sine of negative 270. Okay. Now we're going to do a different type of question where we're going to find theta. In the last 3 examples, theta was given to us, and we were finding the value of sine of certain value that was given to us, where the angle was given. Now we're going the other way around. The sine of a value is given, and we need to find that angle. And there's also a domain given to us between 0 and 360. So we got to scan the entire domain to find where all this is valid. Okay. So again, going to go back, fall back to our triangle, right? And we have sine of theta is y over x, right? Sorry, y over r, my bad. And we want to find where sine theta is equal to 1, okay? So sine theta is equal to 1. This implies that y is equal to r. And where is y equals to r? Y is equal to r only over here, right? Exactly over here, okay? It's not at 270 because there y would be negative r, okay? So there's only one possible solution for this. When we scan the entire domain between 0 and 360 degrees, we have only one possible solution right here, right? So that you have to scan the entire domain, right? Because domain says 0 to 360. And we have one possible solution, and that is at theta equals 90 degrees, right? So that is, that's what we're looking for. So that's your answer, okay? Theta is 90 degrees. Let's do another question. Determine theta for sine theta is -1, given that the domain is from -180 to 360. So again, we're going to fall back on our basic definition of xy and r. Sine theta. Okay, now again, this is because it says sine theta is -1, so that's why I'm writing the ratio for sine theta. Sine theta is y over r. Okay, and sine theta is equal to -1 when y is equal to -r. Right? So when y is equal to -r, that's when we end up with, when y is equal to -r, okay, that's when sine theta is -1, okay? So what does this mean? This means y is equal to -r, and where is the terminal arm? The terminal arm for y is equal to -r just happens over here. Okay, so that's our terminal arm. I'm going to break this, scanning the domain into 2 bits, okay, from -180, because we also have a negative angle here of -180, okay? So I'm going to break this into 2 parts. The first part, I'm going to go in, what color should I choose? Green. Okay, I'm just going to go from 0 to 180. That was not a great choice. Let's use a darker color there. So if you're sitting out on a washed out screen, this pops out a little better. Okay, so that is from 0 to 180 degrees, -180, okay? So scan from 0 degrees to -180 degrees, right? Where does it hit the terminal arm? It hits the terminal arm right here. And what is that angle, okay? So this is, let's call it θ1 is -90 degrees. Okay, so one solution is at theta equals -90 degrees. I'm going to go back and also go from 0 to 180 degrees, 0 to 360 degrees. So I'm going to go all the way from here to here, okay? While I go from 0 to 360 degrees, okay, I do have a second solution, and that's over here, okay? So that is my second possible solution, and that is 270 degrees, right? So again, you go back and scan from 0 to 360 degrees, and you have a second possible solution at theta is equal to 270 degrees. So your final answer, therefore, the final answer is theta is equal to 0 degrees, -90 degrees, or 270 degrees. That's your final answer. Okay, you have 2 possible solutions. When you're solving for theta, given the value of sine theta or cos theta or tan theta, you'll have multiple solutions if you're given an entire domain, okay? You always want to check for multiple solutions. Let's do one similar question, another one. Determine theta for sine theta is equal to 0, given that the domain is between 0 and 540 degrees, right? What is 540? How can we count up to 540? It's pretty simple. This is 0, and this is 90, right? You keep on adding 90, okay? Another way to keep adding 90 very fast is add 100 and take away 10, okay? So this is 180, add another 100 to that is 280, take away 10, 270, add another 100, 370, take away 10, 360, add another 100, 460, take away 10, 450, okay? This will all be so much easier when we work in pi, and right now we're working in degrees. So when you're working in pi, this will be a lot more simpler. You don't have to keep doing mental math. mental arithmetic, and then you just, you'll be using multiples of pi. But for now, since we're working in degrees, 450 plus another 100 is 550, take away 10, 540 degrees. So that is where we want to start and end. We want to start all the way from 0 degrees, go to 360 to 450 to 540. That's the domain we need to scan for our solution, okay? Now, again, let's look at what sine theta, cos theta, and tan theta are. So, or in this case, just sine theta, right? Sine theta is 0. So sine theta is y over r. And sine theta is given to be 0. So this means y should be equal to 0. Okay, so only when y is 0, sine theta is going to be equal to 0. And where is y 0? Y is 0 in 2 places. Okay, we have a terminal arm over here. Okay, that's where y is 0. And another one over here. Okay, so we have the terminal arm along the positive x-axis or along the negative x-axis. So that is y is equal to 0. How do we find the value of theta? So we have to see where this entire this squiggly thing I've drawn, okay, for that is theta. Theta is equal to 540 degrees. Going from 0 to 540, how many times does it touch the terminal arm? It touches the terminal arm here, okay, and that is theta equals 180 degrees. Okay, it also touches over here, that is 0 degrees. It touches the terminal arm here, that is theta is equal to 360 degrees. And since there's an equality sign on these inequalities, right, we also have to include the points on either end of the domain. So that is theta is equal to 540 degrees. So just let's write up the solution. The solution is theta is equal to 0, 180, 360, or 540 degrees. These are your possible solutions. Right, so that is the end of today's lesson. Please try out your homework right away while you've just learned this. This is the best time to try it out. Okay, thank you. Bye-bye.